Ah yes, handheld poorly lit shaky cam. That means I'm in a hurry. So I promised that I would give a edited down version of the live stream. Oh, shaky. Just for people who either couldn't catch the live stream or don't want to watch like a 2.5 hour long live stream, where I would just pull out the questions, put them in a sequence, and then give a time index below. So that's what this is. The reason for the shaky cam and the rough edits is I have to go to an orthopedic doctor tomorrow and find out what part of my anatomy I blew out this time. Because that's what happens when you're a spaz. But anyway, hope you enjoy this video, and I'll get to doing the promised edits of the various parts of the build and the theory documents behind it as soon as I possibly can. If you stacked fast-switching low RDS-on high-power MOSFETs at the output of a 2208, for example, would it actually be like a TMC on steroids? The TMC, well, the MOSFETs are already in an H-bridge, and you have an output. So, but the 5130, I think, is designed to have external MOSFETs. So you could put whatever MOSFET you want on that. They have some specs, and that was, I keep teasing like doing a torque comparison video for like a whole bunch of different steppers, and that's the main thing that's been holding up, is that stupid 5130 or 5160 or whatever. Breaking news! In response to this video, Vatrot has sent over some of these chips, so I will have that review coming out soon. We now return you to your regularly scheduled question and answer. But yeah, that has the board and the controller, and then you put 4 little MOSFETs and an H-bridge on the chip. So yeah, you could make a Trinamic on steroids with those, which is why I'm excited to see them. They're just not around yet. The 5160s are at Vatrot now? Ooh. Well, if that's true, I will get some post-haste. High wind rails are pretty expensive. These I got for like $8.80 a piece, and I wanted to give them a whirl. And I sort of designed everything around it like sight unseen, just to see how they worked out. And then I did that video with like the rebuilding and everything, because I found out there was like debris in there and the bearings were the wrong size and that type of deal. But unfortunately, even with the bearings the right size, after I used it for a while, they developed a little bit of play. Now, I don't know if that was like an initial settling in and now it's going to be fine, or if it's going to continue developing play. So it was actually affecting print quality. So as far as a cantilever printer like this, for the Z-axis, I actually went to Adafruit and I got a heavier duty rail. This is one of the 15 millimeters. It's still not like a Highwind or an Ico or Nikon or something like that. It's a clone, but it has dual layers of recirculating bearings, and there's a lot less play in it. But it was pretty expensive. You could probably still do it with one of these for a printer that's this small, but I thought I would give that a try too, so I could kind of do it all at once. Also, I decided to go with a direct drive extruder, and that was obviously a lot more heavy. So anyway, I don't know how I'm going to show you these things here. Grab the camera and move it around. What I did with the cheapy rails is I took one of there we go. I took one of these V-rail wheels, put it on the top with just a couple of screws on the axles to tension it against it. That way, where did I put? Oh, there it is. Because these have, and I don't know if this play is intentional or not, because these say they're self-aligning, so they do have slight movement this way, but they were rattling around. So what I did was put wheel on the back to kind of tension it against there, and that cleaned up all the slop. And I did that on the X and the Y axis. It prints without it. The problem is you hit resonance really easily on that axis because it's kind of free moving, and you get these little brrr, like wavy patterns in the print, which was obviously no good. However, if you did use these rails parallel to each other and sort of pre-tension them to each other, or if they sold, and they do say they sell these pre-tensioned, as opposed to this, which is obviously free moving, that would probably be alright. Unfortunately, those were not the ones that were on sale. But if you could get these and pre-tension them against each other, or strain, stress, whatever, against each other, that would keep that from rattling and be okay. Now for this guy, I wanted to kind of see what the limits as far as length were on this, so I just used a standard Prusa bed, so that's like a 220 by 220 bed, and see how well the cantilever would do, because these do have, you know, they're going to, any cantilever design, have some kind of flex, and I want to see how well the rails would deal with that. And it ends up they do deal with it very well if you mount everything rigidly. I haven't really had problems because of cantilever sway, except a little bit front and back on the x-axis, which isn't quite as vital as the other direction. But to hedge my bets, I designed this so that I could run a longer rail in the back and then stick a second rail on this side, and then have more of like a standard, you know, i3 but with linear rail type deal, and then be able to tension that and not have to worry about the wheel on the back. I had a lot of luck with the z-axis on, it's buried, my test bed printer, where I used a pillow block to take the strain off of the little shaft coupler and to keep it straight. I had absolutely beautiful layers on that printer. Here's one of the prints from that. Hopefully that'll focus in. Nope, not high enough resolution. Anyway, they were absolutely beautiful, so I figured I would try using a thrust bearing. That didn't work great, so I went back to the radial bearing with the drill stop on it, and I'll show you that when I get to doing videos for this. It seems like a belt pulley would have tensioning and cross-axial alignment issues. Yeah, that's, don't really have those kind of issues, because this right here, I'll loosen up the belt here, is kind of self-aligning. So this isn't rigidly fixed. And then I have 2 millimeters of float on either side of the pulleys on the cart, and you could work it back and forth a couple of times by hand, set the belt in the middle, and it sort of aligns itself automatically. The thing I was concerned about was different step rates per millimeter along the axis because of tangent of just the very slight belt angle here, but it actually doesn't seem to be an issue at all. And looking at some printers like Creality, I think, I don't know, some of them that use the V wheels, they have an extreme angle onto where their belts are stationary, and they don't seem to have any problems with them. So yeah, it didn't seem to be an issue, although I did think that at the beginning. Does it cap your resolution to the single step? No, it's the drivers don't. It seems to be the way that it works. I read through this a couple times there, Scott, is that regardless of what stepping you pick, it's still using the steps on that table. It'll just additionally pulse on the intermediate steps if you turn it on, and then there's a little bit of extra DSP going on. That could be good or bad, because it does some predictive stuff and it can overshoot. That's one of the things you have to deal with when you're using microplier. Somebody did on reprep.org a big study on like the overshoots, and it didn't seem bad enough to me that it would outweigh the benefits of getting 4 times higher step rate versus like 16 times interpolation. So these were all the various modes of stepping where I went to go and test what the torque was at various voltage ratings, as well as using interpolation and not. And the highest torque that I had found for these with my macaroni curves was using spread cycle at higher voltage in quarter stepping with microplier interpolation engaged. So that's why I went ahead and used that for this. Mention trying clipper. Yeah, I stocked up on Raspberry Pi Zeros and the regular Raspberry Pi, so those are all ready to go. One of them actually has clipper on it already. I'm just too busy to mess around with that too much. So regardless, don't want to get too off track here. Yeah, steathchop seemed to be a little bit weird depending on the features. So this wasn't, the point of this wasn't like ultra silent though. And you'll see when I do a print that it's actually pretty quiet, even with quarter stepping and spread cycle and, you know, with the interpolation at 24 volts. Another problem was, I don't know if you've messed around with linear advanced at all, sometimes it's called pressure advanced and other things, but it seemed to be sending a whole bunch of random signals to the extruder and making it make a bunch of noise and glitch out, and it just wouldn't print. And I saved the first print I did with that. I don't know if you'll be able to see this or not, but it just looks like fuzzy on the outside. It was a freaking disaster. And that was from everything just being normal and then turning linear advance on and trying to tune it. So I jumped onto the Marlin GitHub. I went to the RepRaps stuff, and it wasn't working right at all. And so then I stumbled across somebody who actually did put a probe on it and saw that the pulses were much faster than one would want. So I went down to, is that an advanced? I went down here to the stepper tuning, and you have a couple different parameters you can set here. One is the delay between step and direct signals, which you require a minimum there. It's in the Trinamic data sheets if you want to look it up. But I set that much higher than necessary. That didn't have too much of an effect, but changing the minimum pulse width did. They were Scott at Marlin recommended 2. I just set it up to 4 just for kicksies. But the thing that really helped was limiting the maximum stepper pulse rate. Now, since I was trying to limit everything to single stepping regardless, I don't need a higher pulse rate than 10,000. So as soon as I set that down to 10,000, linear advance behaved itself. So linear advance is engaged, and as long as that maximum stepper pulse rate stays low, it works fine. As soon as I set that up to either uncapped or to the like 50,000, or what do they recommend, 400,000 for the Trinamics, the extruder just it freaks out and it prints out all fuzzy on the edges. So anyway, that's what seemed to do it. So just try that out if you're having trouble, if you had trouble with linear advance and decided to just can it for now. Try limiting the pulse rate and see if that works. It worked for me. It's repeatable, and then just raise the stepper pulse rate up to whatever you need. I bumped it up to 20,000 so I could have room for, in case there was some overhead on movements, the 250 millimeter second movements or something like that, and add additional pulses in there that weren't double stepping. So regardless, that seemed to work fine. What other sneaky things that I have to do? What's that? I believe there's a known issue if you mix 2130 and 22.8 and you have to lower the pulse cap. Oh, well, there you go. Works for me. I can confirm that issue. I had 30-tooth pulleys on the X and Y axis, and I had 20-tooth pulleys 30-tooth on the X axis and 20-tooth on the Y axis. And a lot of these things, the features just weren't working right. It was going all freaking goofy. As soon as I switched out to 20 and 20, it got beautiful. So I didn't do enough testing to file a bug report. I don't know if that had to do with the step smoothing or the S-curve, S-ramp generation, whatever that is. But for some reason, that math was wacky. I suspect it may have also been that when you have to enter these firmware steps in, this was 40 because it was a nice even integer. This was 26.266666 repeated, and that just didn't work right. As soon as I changed it to an integer, it was fine. So I know that 8-bit processors are not great with floats and doubles. That flipped it to a double. As soon as I turned them both to ints, that was fine, but they were also both even numbers, so it could have just been an interpolation thing, and then it was fine. Or a rounding error. I didn't track through with all the math to see where it truncates and if it's using, floor ceiling function. And I don't think that, well, I'm not compiling with Arduino. Platform IO and VS Code, I don't know if they're using the standard C math libraries or not, so I would have no idea where the floor, ceiling, and truncate functions go. I would have to actually run those tests. And life is too short. All I know is when I changed it to integers, it was fine. So bear that in mind. Alrighty. This is old-ass software. Can I say ass on a live stream? It's old software. Forget that I said it. Anyways, yeah, if you're unfamiliar with 123D, it was the freeware software before Fusion 360, but it's direct solid modeling as opposed to like quasi-history-based parametric what's it that Fusion 360 is. I like 360 for very prescribed things, but for just like playing with shapes and stuff like that, I'll use 123D or other direct solid modeling. My first CAD class was 1995, 1996 or something like that, like freshman year of college, and we learned direct solid modeling on silver screen and then did like some AutoCAD stuff. So I just got used to sort of like messing around with it. DSM is a feature locked version. Yeah, there's a quasi DSM in Fusion 360. They call it like history list mode, but you still have to use their dumb like right click toggle radius pull down menu thing, and it's annoying. I like this much better where you just like start with a drop a primitive and then move it around, just for like knocking out things like this. Are the V wheels original open builds V wheels, or doesn't it matter anyway? I have both. Where is my wheel box? Like these are just AliExpress jobbies, and then I have bags and bags of like original open build stuff. I tried 3D printing these, but they're never exactly circular, which is unfortunate. And then generic bearings. The bearings you get from open builds and the I'm staring up at the monitor instead of the camera. The bearings you get from open builds and the wheels they're much better, but as far as the wheels themselves, as long as you get them properly turned out of Delrin or Palm, the import wheels are okay. The tolerance was a little bit looser, but it doesn't seem to matter after they wear in a little bit. However, I still mostly order them from open builds because they're right there. They're across the river, so they're pretty close. And like I said, their bearings are a lot better. This one has the cheap bearings in it, and they bind up so much. Even if you put a shim in the middle, they still bind up. They're really junky. Oh yeah, this is the last thing. So that's one of the reasons I went with, usually for experimenting, I'll just do like the ramp sandwich type deal. But I like that you can pop it out and pop 32-bit stuff in, so you can compare features back and forth between them. On the anything that derives from Smoothie uses the LPC series 32-bit chips, and I mentioned this briefly a little while ago, that some of the features don't work so well with those because of a bug, and I tried different combinations myself to see what would and what would not work, and nope, that's not the thread, and I couldn't quite track it down. But if you go to this page, this fellow, under issues on Marlin, problem printing when combining certain options. He had a problem with the MKS S-Base, which uses the LPC series processors, where all of these various features, he was getting like Leaning Tower of Pisa type shifts when he got it. So if you're going to switch to like a rearm, or you're using an MKS or anything that uses an LPC, I think the Big Tree Tech SKR uses it and that type of stuff. Yeah, check out that thread. I don't know if that's a bug that's going to be fixed or not, but unfortunately I couldn't pop a rearm in and test these as well, because that uses an LPC series chip, which hopefully that can be solved in the future. I'll point the mic over there so you can see what this sounds like. Oh, are you hearing that pulsing? Can I explain the extruder? Yeah, it's a 3-to-1 ratio belted extruder. So it's ugly. It's the pre-beta version. It was just something that I threw together because I wanted to have a belted extruder that works pretty easily. But yeah. Are you going to post this printer on Thingiverse? I want to post it somewhere. Like, I've tried a couple other, if anyone has suggestions, let me know. A couple of those hosting sites, and either their interface is goofy or their search is goofy. Not that Thingiverse's search is great. So I might just continue using Thingiverse. I can go ahead and post the STLs. I would definitely have to clean some things up, and I do things for, like, when I'm considering like a pre-beta or a proof of concept type of a thing. I do things like using wood screws everywhere instead of using like proper inserts or redesigning so that you don't need that type of thing. So I would have to do a redesign, but if there's interest, I'll post them up, and then there aren't too many printed parts, so it is something you could just try, and then if you don't like it, build something else. But yeah, I'll definitely put the extruder up there as well. Put it on GitHub, that way people can send PRs to help improve the documentation and clean up stuff for you. Yeah, that's probably the best way to do it. I mean, there's really no collaborative work on Thingiverse at all. I actually, when GitHub sold to Microsoft, I pulled all my GitHub stuff down. There might be like one project file up there now, but maybe I could use GitHub. I blew the voltage regulator on my Arduino a bit back, and the USB provides the 5 volts currently. Should I remove D1 from the ramps board and give it an external voltage regulator? Rich, the way that I have mine set up is, if you can see, this USB cable back here is powering the ramps board, and I have D1 removed. So I just use, I mean, obviously I'm in, well, not obviously, you didn't see it. I'm in Pronterface. There we go. But when I'm not in Pronterface, I just use a powered hub. It's buried back there, so I can't grab it. So then just use USB for the whole thing. Doesn't the weight of the extruder add ghosting at higher accelerations? How about flying extruder like in a Delta? Yeah, there was a printer, can I reach it? Maybe. That I was working on that I wanted to try a, oh, okay, I'll grab it down. I don't know if this will fit in frame. Like future design, this was a cross gantry, and I was going to have a separate flying extruder up top, but never got around to finishing it. So I may finish that one of these days and use that for one of the other videos. How is the print bed attached to the linear rail? Whew. That's a little quirky thing that I will have to make a better version of before I print any STLs, because the print bed is glued to carbon fiber, and then I have blind nuts through the carbon fiber that then bolt into a 3D printed carriage, and then that rides on the linear rail carriage. I don't know if that's asking too much for like a DIY printer or not, but... Are you using one of the chopper presets, or did you define your own? Good question. I forgot to talk about that. Yeah, I'm using the... for those who don't know what you're talking about, I will find it and then pull it up so I'm not covering up the printer. Yeah, I'll put this in front of my face so I'm not covering the printer. You can see me a little bit. Anyway, if you go to Configuration Advanced in Marlin and you go down here, this section is the chopper settings. I use the default 24 volt settings, and they tweaked those. I guess I can get that out of my face now. They tweaked those from a few months ago, I think, and they work a lot better, so that the steppers work a lot cooler and they're much more well behaved. Glad to hear this presets work better. I spent a night or two scoping out the chopper frequencies when I went to define the new presets. Yeah, they do work better. Actually, some of the guys over at clipper have worked a little bit more with tweaking the settings, and the Marlin settings now are close to what they came to as like kind of the best bang for the buck settings, and that was pretty close to like what I was feeding in the advanced options for the Trinamic driver. So it seems like as time is going by, they're getting much more tweaked in. 3:30 a.m. Oi. 10-minute benchey. I did a 28-minute benchey at 0.2 layer height, so that wasn't too bad. Note that after the stream, I actually did try to print a 10-minute benchey, and unfortunately it was impossible with a 240mm2 cap and a 0.4 nozzle, which made me very sad. I did manage to print a 13.5-minute benchey, and man is it ugly. Seriously though, it was impressive to watch it try, and I'm amazed that the filament just didn't spill into a rat's nest, but holy crap does this look like garbage. Definitely have to tune the extrusion and increase the cooling at those speeds. So I slowed it down to an 18-minute benchey, and it looks a lot better. It's still garbage, but you know, definitely looks better quality than 18-minute, and I was very impressed that there wasn't a lot of ringing. And then I printed out a tiny little baby Groot for my wife to make myself feel better. Oh, and here was the 28-minute benchey that I mentioned in the stream. What is a print bed surface? The print bed surface... This was something that I kind of gave up on the experimentation because I ran out of time as well. But I wanted to do like cheapy removable printer. So this is not spring temper steel. This is just regular galvanized steel. And I wanted to see how well that did with just regular magnet. This is just standard refrigerator magnet. So it's not high temperature. It'll do up to like 80°C. But it's super cheap. I bought an entire roll of this for like under 10 bucks. And by an entire roll, I mean an entire roll. Here's the biggest magnet you've ever seen. But anyways, as far as what the print surface is, it's this. This is just PEI. So usually there are a couple different types of these sheets. Like if you get this from like Amazon or something, you could probably get this for like Dickblick's. Okay, yeah. So if you can get this from Amazon for like 10 bucks or 15 bucks or something like that, and it comes with the 3M tape on the back already, so that can save you some trouble. But this, I think I may have gotten this from Dick Blick also, or Pearl Arts or something like that, but it was like $2. And usually when it's optically clear, if it says like optically clear or crystal clear, like it's PEI, otherwise it's not. Yeah, I mostly only print PLA. I guess I could talk about that a little. I have a spool of ABS that's probably 2 years old or something. That's the last time I printed with ABS. I really don't like... I like the fact that PLA is a bioplastic and it's compostable and biodegradable and all that kind of stuff. I just feel really guilty pumping, you know, complex polychain, non-biodegradable or slowly biodegradable plastics out into the world just for my silly experiments. So for prototyping stuff, I was just using a lot of PLA and I got used to it. That's why I had the series on, like, you know, different methods of heat treating and like tempering PLA, because I was like, if I could get this stuff like a little stiffer, a little stronger, like I could use it for more things, and that actually works. This, if you'll notice, this motor is mounted directly to a PLA printed part. I annealed that in boiling water, so that's why that's not melting to slag touching the motor. It's spaced off by a couple washers too, which seems good. But it's same with the x-axis and the... By the way, I'm pushing these axes around because I have the protector, the diode protectors on there. Otherwise, don't do that. But yeah, so these are all mounted as well. These are all annealed in hot water. Annealed PLA say it's one of the 3 stiffest materials available. Yeah, it's pretty stiff. CNC Kitchen does. Yeah, I like that channel. He's a good kid. So this was what I just printed. Having a real hard time focusing on that, aren't you, buddy? Looks pretty good. Yeah, that was the shape that I had showed in the video. that just had all little curves on it, because I wanted to have the kind of like rumple section, and this is like a double. This move right here, back when they were having problems with layer shifts with Trinamics, this would like for sure send it layer shifting. So I know that if it's printing that okay, then like the chopper's dialed in well, there's enough torque on the motors and that type of thing. And then nice sharp edges where it's supposed to be, nice round edges where it's supposed to be. These little scoops turned out pretty well, and you can see all the dividing lines between the different sections. So all the motors are Niemert 17 now. Any numbers on nanometer? Yeah, let me pull up the documentation and see if I have exactly what they are. Alrighty. I don't know if you can read that or not, so I'll read it out to you. So for the question on the torque rating of these motors, the axes are, and these were, I think these were all, yeah, these were all Ziltech, or they have the same versions from Stepper Online. If you never seen Stepper Online, that's a great place for steppers. It's just takes a while to get there, and sometimes you can find them cheaper in like 3-packs on Amazon or eBay. But anywho's, yeah, each of the axes, these are the 1.7 amp steppers, and then the extruder was this guy. But I'm not running them at full torque because the Trinamics can't get a 1.7 amp stepper really cooking. So you're not going to hit that 85 ounce torque number. It's more like 50 something. Those numbers are linear. So if you're saying, and Trinamics are weird because you tune them to RMS value instead of peak value. And if you've worked with electricity, RMS and peak, if you're going from RMS to peak, you multiply by 1.41425. And then if you're going the other way, it's 0.707, you know, whatever, 1. But we just say 0.7. So you would be setting 1.7 to RMS is 1.19. And we're going to go for, we usually run at like 80-85% to leave a little bit of thermal headroom too. So for 1.7, 0.85 times 0.7, then you're going to want to run those 1.7s at around 1 amp. But I don't have them cooking that much. I have them cooking at 800 milliamps. So we're actually losing 20% of our torque. So if our extruder is 59.59 times 0.8, it's actually, yeah, in the 40s. There are steppers that have a maximum working current of 0.9 amps. You can get them from Stepper Online. They don't have them on Amazon. They don't have them on eBay. And I didn't special order them because I wanted to use really common steppers for this and see how it tuned in. But you can get more bang for the buck out of your Trinamics there. If you look here, I have, this says efficiency ounce per amp. All I did was I took the output and the current and divided. So the higher that number, the more efficient the extruder is. And it's, you know, it's a subjective ratio, but it lets you compare one to the other. Now that's going to correspond roughly to the balance of your voltage and your inductance. The inductance, however, you can get a whole lot of torque per amp, I guess, a high efficiency rating, if you have higher inductance. But the higher your inductance is, the lower top speed you're going to have, because as you are turning faster, you're pulling more, or you're generating more back EMF that's cutting into your headroom, and it's limiting your top speed for your motors. So it's really a balancing act, and that's why I did those, you know, torque performance curves, just to see what was best. Since these are geared down 2-to-1 and I had to do increased step rate, I went with lower inductance motors as opposed to the higher torque at lower current motors, as kind of, you know, the lesser of the two evils, I guess. And these have more than enough torque to deal with it. You get higher torque at higher voltage, right? Correct. Up to a certain point, related to the operating voltage of your motor and the inductance. So there will come a point where you can't raise it anymore with respect to a high inductance motor. But a lot of the motors that we have these days, they're like single digits inductance, millihenry. So it'll be like, 4 or 5 millihenries. But if you have like a 17, 19 millihenry, you're still going to benefit from higher voltage, but you're never going to reach those higher top speeds. You will, however, have higher low end torque, which is nice. What brand of PLA are you using? I am using Atonic Filament PLA. The color is dark cherry red, and I really like. This is the first time I've used their filament. I figured I would do something special for the stream, because usually I print in primary color, so I wanted something that popped. Not thinking, hey, you're a moron, and it's going to blend in with your stupid curtains, but if I stand in front of it, it looks okay. So anyway, it's a pretty nice color. And I checked the... this is actually... Last night was the first time I printed with it. Where are my calipers? There they are. Yeah, so I always check the filament diameter, and theirs was spot on. It was a little bit pricey, but it's pretty nice. Sponsor me, I'm selling your stupid filament if you're watching this, which you're not. Let me see. Make a B channel for videos you don't think are good enough. Yeah, maybe I could do that. Yeah, like I don't. If you're watching me for a while, you know that there was a period of like 2 weeks, a few months ago, that I didn't post anything because I was compiling extruder math, and I just did tons and tons of extruder math and all the geometry involved and things like that, and went on this 2.5 hour rant, tried to cut, it was actually longer than I cut it down to 2.5 hours, and then I cut it down from 2.5 hours to 1 hour and 45 minutes, and then I was like, well, I need to break this up into sections because I can't post like a 2-hour video where I'm literally just talking math at a camera for 2 hours. But there weren't convenient breaking points, so that was like 2 weeks of work where I was like, oh, this stupid video, I'll come back to it later. So I will be doing an extruder math series, but I'm gonna have to plan ahead and not just talk numbers at a camera for 2 hours. Oh yeah, but about the 32-bit stuff, that was part of why I wanted to do the Ramps Mega Sandwich, because you can just plug a rearm into there. And it would have been nice to do the A-B between the 32-bit and the 8-bit, but a lot of these features, if you look at that Marlin GitHub thread that I posted with the advanced features, toggling them on and off, and they weren't working. Unfortunately, I couldn't just keep that the same and plug a rearm in there because the LPC chips have that bug in Marlin. And man, let me just complain for a second about that. So I still have my other printer over there, the one that's usually in the videos, that's 32-bit right now. And I have all the advanced features turned off except for, I think, S-curve acceleration. And I didn't know that bug was still active. It had just like popped out of my brain. So I tore that thing apart twice. I ordered a new Z-screw, I changed the motors, I reprinted the Y-axis carriage, and then stumbled across that thread on GitHub, and they were like, oh yeah, everything's prints slightly tilted if you enable these features, and I was like, So anyway, look first, act second, I guess. This is around the same time I discovered TMC5160 steathchop doesn't like sudden speed and direction changes. Yeah, unfortunately that's true. The 2208s use steathchop 2, and there is in addition to the PWM voltage regulator, it has a pre-regulator, so it, like, overall it steathchops better than steathchop 1, but it seems to be thrown off more by sudden changes in like acceleration, that type of thing. I would like to try all of that with like junction deviation as well and see how that is, but I know that it's really goofy with like linear advance, so another thing to try in the future. What does the motor's protection look like? I have one right here. Focus, Daniel-san. Here you go. It's just one of the step stick protectors, and these are all diodes on the board, and they clamp the output to the rails, so it clamps your output to ground and then whatever your V plus is. This is also very nice because if you're running Trinamic drivers right up around their limit, even if you're not thermally throttling, because of that back EMF, you can get overcurrent warnings that trigger the chip to... It's basically on the same mechanism as like ground fault and thermal warnings, and so it temporarily shuts the chip down until a particular number of cycles go through and it doesn't see a fault. But that's like really fast, like microseconds fast. So it manifests itself in when you go around a corner and it hits an overcurrent, shuts off just for nanoseconds, and you shift over and then it turns on. So the layer shifts aren't from like not enough torque or from thermal shutdown. It's just from that back EMF making it, you know, shift the layer essentially on a corner, and this helps with that by clamping the voltage. So and that's a test you can do yourself very easily if you feel like possibly accidentally blowing up the Trinamic, which I have for the sake of science. VD says, I got my TMC2208 on my Delta and I can print fine at 80 millimeters a second steathchop with linear advance, S-curve, and junction deviation. Well, that's interesting. I will have to do some experiments swapping out the 2208s and the 2130s because I didn't test the 2208s in steathchop with S-curve acceleration. But these were skipping. It could also be some of the wacky settings that I had to do with the step race to get linear advance working properly, but we'll see. So yeah, maybe steathchop 2 on the 2208s works a little bit better. But it's good to know that's working for you. VD says, yes, steathchop 2 makes a big difference. Yeah, that might be it. I'll have to give it a try. Because like I said, I usually use 2208s and I never had any problems with the steathchop. Any thoughts on Cartesian cube with ball screws on X and Y? I have not tried ball screws for the X and Y. One of the problems with ball screws is, and just lead screws in general, is they have a ton of rotational inertia. So you'd think like that you're not really, you know, you don't have that same kind of looseness that you do on a belt system, but you actually have a problem of the rotation at the end. So you have a little bit of magnetic spring back between the stops as well. No, not for the X, just the Y to carry the heavier load. Yeah, so that's a little... I would imagine there would be probably a sweet spot between the diameter of your ball screw and the length of the axis, because as you're adding more length to that, you're adding more rotational inertia and you're putting more strain on the stops. But I haven't tried, other than like CNC stuff that moves very, very slowly. I haven't tried it. All right, I guess that's it for now. I've talked long enough. Thank you all for tuning into the inaugural stream here. Thank you guys for the super chat tips, and I'll be back with more videos soon. So like I said, the next few series of videos are going to be just picking apart like what I learned from this whole experience. I hope you got something out of this stuff, and yeah, have a great weekend.